Hi everyone. Today's topic is about unsupervised learning, but at the end you would see that I use supervised learning for further analysis. The data is mm, the major data actually was provided from this book, Mastering Python for Data Science. However, I add some more data sets to make it more complete. The dataset that I use is un.csv file, which you can get from the publisher's website. In addition, as you see, uh, I added unemployment rate, population, and number of tourists who arrived in that country as extra variables that I add. So even in your projects, either from Fidelity or your individual project, maybe your data set is not enough or you want to do further analysis, you can merge your data with other data sets. So as you see, the first data set, which is un.csv, is about some socioeconomic data of the countries, such as the region or the continent, on fertility rate, contraception, male education, female education, life expectancy of male and females, infant mortality rate, GDP per capita, percentage of male who generate income, and same for females, illiteracy rate in male and females. So, and again, on top of the added population, number of arrived tourists, and unemployment rate. So what I want to do to use economic information or financial data to cluster my countries, and then look at the clusters and see what is the makeup of those clusters, what makes these two clusters different from each other, and see if I can predict those clusters using other variables that I haven't used for clustering. So first part is importing the packages and functions that I need from the package. So it's pretty similar to the previous packages. Although at the end, as you see, I imported warnings, and the reason for that, when you run your projects, you might face some warning and errors. You try to fix them, but for presentation, maybe it's not that much great to include those warnings. Maybe you can just let Python to exclude those warnings. Having said that, I already mentioned 4 datasets, but I kept the same name, so un.csv, which is provided from your Moodle. You can just change the address and bring in your Jupyter notebook and do the further analysis. Look at my dataset. So I have 16 columns. And as you see, we have 207 countries, which is some of them you have NAs. Like, for example, in female and male education rate, we have a ton of NAs. However, some information such as population, we don't have that much NA or empty cells. For region, we have more. Now let's look at the distribution of empty cells in each row. As you see, over our data, I called method of isNA, which just bring back the NA cells, the cells that are null. Again, in terms null, NAs, and empties are same. So I may use one of them, but I just mean the same concept. So over those NA cells, I want to sum up them based on row. So I said axis equal 1 means I want to look at how many NA cells I have in each row. Then I called method of sort over that. What does it mean? I want to sort the rows based on how many NAs are in each row. And as you see, I changed the ascending properties to be false, which means that the sorting here is descending. So I have the most emptiest country on top, which is Andorra and Tuvalu. And I'm looking at the head of them, like first 5 of the data. So having said that, for Andorra, Tuvalu, Monaco, and Western Sahara, it seems there's so many empty cells, so I don't have that much information in these countries. Maybe subjectively, I want to just get rid of them. On top of that, if you look at the CSV file, you can see there's a country of Yugoslavia or Yugoslavia. I'm not sure the pronunciation, but this country is not existed anymore. So I'm going to drop that country too. So by calling drop method over data and specifying a list that has the name of countries that I want to get rid of them, I mean get rid of their information actually, because they are either are not existed, and also there's no I don't have that much information about them. So I drop those countries here. By the way, anytime that you want to add some comments on the Jupyter Notebook, you can just pause the video and just add some comments so it makes sense for you. Or let's say, for example, in this part, look at the distribution of empty cells or NA or null cells on each row. Maybe you can just look at the part of the code separately and try to run them so it makes more sense for you. Okay, let's go to the next part. So you might heard of outliers. Basically, in some cases, it's really good to get rid of outliers, or maybe we can recategorize our data, which we talk about them later. But anyway, in this data set, I have some numerical cells, and in those cases, some of the countries outlier, for example, they are highly populated, but they have a small population, or female education and male education, or other information of the columns. We have some outliers in them. So you want to just get rid of them, and you can look at this Wikipedia link about information of what makes outlier. Basically, we look at the mean of each column, and if there's some cell values that are that their distance from the mean is more than 3 standard deviation, we just drop them. So as you can look at here, I look at all of my data from index of 1 in the column, because index 0 was, if you look at here, let me show it to you, the region, which is a categorical data, is not numerical, so I cannot find outlier. And the country name was basically index. So I just want to get rid of that string or categorical data. Then I drop the values that are NA, because doesn't make sense to look at outliers on NA cells. And 3 here means we look at the data which are within 3 standard deviation from the mean of each column. And as you see, like for example, in the first column, we have 202 observations or cell values that that are within 3 standard deviation. In some of them are less. So what can we do? Basically, just get rid of them, because we are not working with them, and they are not practical. As you see here, I just assign those values that are within 3 standard deviation to a new data frame with the name of DF, and when I look at the general information of that DF, which is a new data frame, you can see now instead of 207 countries, I have 186. So basically, I exclude the countries that don't have that much information. On top of that, in some of the countries I had outliers, just wanted to get rid of them because it's not practical for me to work on them. Okay, let's go to the next part. So you might remember in the previous classes, whenever we had NAs, we had either drop them or impute them, or there's also some other method which or about interpolation. If we have time, we'll go over them. Anyway, so here I'm just showing you sometimes maybe on top of dropping or imputing, there's some other ways. Like here, look at the region variable. So as you see here, there's 7 countries that I don't have their region. If you look at the data dictionary, which is one of the earliest blocks in this Jupyter notebook, you can see region basically is just continent. So if you know the country's name, you can find their region. For example, if you look at here, Algeria is in Africa, Argentina is America, Australia is Oceania, Austria is in Europe, and like up to Brazil in America, France is in Europe. So having said that, I just can fill out these cells by knowing one of them. Just country. Country is not this basically my column is just an index, row indexes. So calling the row index of country names and column of region, I put the actual continent name and I fill out this variable. So let's do a visualization of just one of the variables. We had a class that I went through some other visualization, and I also show you we had scatter plot, histogram, pie chart. We have other figures that depends on your project. You can Google and find the appropriate type of figure you can use. You have seen that we use visualization for 2 reasons. One of them is data cleaning, and the one providing some descriptive explanation or statistics about your data. Look at the looking at the region column, which is the continent. As you see, we have 5 categories, and these are names. We cannot they are not numerical values, so we cannot use them for machine learning algorithm unless we change their type or convert that categorical column to several numerical column or several dummy variables. So here I called get dummies, which is a pandas function, and trying to change region, which is a categorical variable, to some new variables which are dummy. They are 0 or 1. And also I dropped the first of them. As you might remember, I've talked in the class that one of the columns could be predicted using other columns. So it's a good practice to drop them. There's a correlation between the columns. So by dropping one of them, we remove that correlation. So anyways, more about the statistics, and you can just Google to see how to convert the categorical variable to a numerical. So basically we call it encoding. So there's 2 types of encoding: hard encoding and label encoding. So here I'm using hard encoding. Anyway, I mean, we talk about hard encoding and label encoding later. And I've seen that some of your friends already did label encoding, which is totally fine. As you see here, for the rest, since after converting my data to dummy variables, now I have numerical columns. I can call fill NA method to fill out those NA cells with the median of the columns. And after, if you look at the information of the DF, which is our data frame, you see now all of them are numerical and there's no NAs. Also, number of observations is 186 now. Okay, after data cleaning and preparing the data, now it's time for unsupervised learning through k-means. As you might remember, in k-means, we try to categorize our data in several groups based on their similarity. What I mean from similarity, basically, we have some points that we call them centroids, and we just find the closest data point to that centroid. So if we have we want to cluster our data in 5 groups, we have 5 centroids. If 2 groups, we have 2 centroids. These are basically, you can imagine as the center of clusters that, and all of the points will be associated to a centroid, which is the closest centroid. So usually for clustering, we use more than 2 or 3 variables. So imagination is kind of difficult because for humans, imagining more than 2 dimensions and 3 dimensions is really difficult. Here I use 3 variables of 3 more economic variables of GDP, percentage of male and female who generates money. So still I can show them kind of because we can visualize with 3 variables. Although it's not very highly recommended. So basically people are more interested 2-dimensional visualization, but still for human eyes it's easy to capture 3 dimensions and visualization with that much of that dimensions. So we want to categorize our data in several groups, but we are not sure how many groups is needed. Maybe 2 clusters, 3 clusters, 1 cluster, even 5 clusters. We are not sure. So basically, we do iteration, and as you see, I define a range variable. So between these ranges between 1 to 7, because the last one is not included. So I try to see what happens if I have 1 cluster, 2 clusters, up to the 7 clusters. And as you see here, I'm calling k-means function and dividing my data based on these 3 variables to k. Each k is an iterator in the range between 1 to 7. So, but what's the measure of saying how many clusters is good? Basically, if you can separate your data in distinct groups, which are highly separated from each other, it seems that you have a good clustering. Having said that, if data are fairly separated, it means their distance to the centroid is short. So doesn't matter how many centroids we have, but if we have, let's say, 3 clusters, each cluster has a centroid, and then we capture the distance of each observation to that point, which usually we are talking about Euclidean distance. There's some other distances too, but anyway, so generally if you have more centroids or more clusters, the average distance to all of the centroids are less, but maybe it's not that much good to have so many clusters. Anyway, so after clustering, we want to look at 2 things. One of them is center of the centroids and the distance of the points or observation to all the centroids. So after capturing these 2 measures through cdist function, we want to find the closest centroid to each data point and also the index of those centroids, which you can see it comes from argmean and mean. Mean basically calculates the minimum distance, and argmin calculates the index to associate it to that centroid. For example, is a centroid with index 0, 1, 2. For better understanding, I recommend to go in the details of this for loop. Look at the dist all what it made of, and you can see that you have for each observation, and based on the how many clusters you have distance to the all the centroids, and basically with argmin you find what was that centroid, and with mean function here, or sorry, mean method here, you can find the distance. Also, in the last line, we want to find mean of the distance of all observation to all centroids. Basically, what's the application of the last line? So if your data is clustered into separate groups, which are fairly separated from each other, the mean of the distances or average of the distances is minimum, because we find very close centroids to some data points, and so we are more happy. So what does it mean? The data is not clustered in the very spread data points. So we look at that measure too. So at the end, what we want to do, we want to look at two things. First of all, based on number of clusters, what is the minimum, what is the mean of all of the distances to all the centroids, and which one makes we have, and look at the changes of those means. What I mean change of the mean. For example, if you have two clusters, what's the distance? If you change it to 3, what would the minimum mean of the distance after that? If you change the cluster to the 3, 4, 5, up to n, what is the minimum distances? So in the next block of code, I'm showing you the minimum distance of all the points to all the centroids with different clusters. As you see here, when you have one cluster to the mean of distances, suddenly when you change your cluster to 2, the average of the distances or mean is changed significantly. But when you change 2 to 3, 3 to 4, 4 to 5, up to n, there is a lower slope. Maybe based on your idea, maybe 3 sounds better. But for me, since between 2 and 3, we have a huge differences. But after 2, there's not that much of differences in terms of the average of distance of all the points to all the centroids. I'm happy with the 2 clusters, but it's a subjective idea. In your point of view, maybe you think 3 is fine. You can, but you need to explain that. So as you see here, I just make the visualization, but in your project, you should put some explanation. What do you think 2 clusters is good? You should explain about that, and saying that because of change in the mean of distances, not that much great after 2 clusters. 2 seems to be reasonable. Okay, I picked 2 clusters. Now let's do clustering using 2 centroids or 2 clusters. So here I created I initialized actually empty object of clustering, and I did clustering with these 3 variables, and then look at the labels. Basically, I make a new column which has the cluster label. What I mean cluster label, either cluster 1 or 2, but when you look at the result, it's 0 and 1. So it's the way that Python is doing cluster labeling. If you're not having 0 and 1, you can change it to A and B or 1 and 2 or other names that you like. But the outcome of the cluster prediction is just in numbers and starting from 0. Okay, in this block of code, I want to do visualization because I just used 3 variables. I can visualize my clustering very well. So as you see here, I called px function from plotly, and as you see, I just said df is my data frame, x is one of the variables, y and z is another one. My color is cluster labels because I just want to have distinct colors. So for each, since I have two clusters, just randomly, I just pick these two color based on the label of the clusters. The size is 18, is arbitrary. Symbols also I said is equal to cluster labels, because what it does for each label, it just pick one symbol, or it could be rectangle. Here you see bullets and maybe star or other symbols. You can, instead of just assigning labels, you can make a list with two inputs or two elements for saying that what would be the first symbol and what would be the second one. Opacity is just how it's talking about how heavy is your color, how distinct you want to have. If it's close to zero, means you have very faded color. And I put a margin in that, so I don't go that much in details. We can Google it, find more details, and probably can add more things. But let's look at the clustering. So as you see, the clustering is pretty distinct. So as I said, we have two clusters. There is two centroids that you cannot see because they are imaginary points. For example, for the red dots, it should be somewhere in the middle. And in what we did previously, we look at the distance of all of the points to that middle point, which is the centroid. And for the other color, other clusters, we have, which is the purple color. There's this point in the center, we call it centroid, and we look at the distance of all of the points to that point. Anyway, let's, instead of having 3D view, let's look at 2D view. So I go upward. So if you see, when I do 2D, it seems that they are not that much separated, right? And so if you do 2D visualization, sometimes very hard to say that our data is separated, because as you see, we have some limitation in 2D. Or let's look at from this view. In this view, still they look separated. Let's look at the other view. If I change to this view, still maybe it looks kind of mixed. But the reality is, because we are having, we have 3D, we have three variables. Actually, they are fairly separated, but the thing that our eyes have limitations. So if you have more than three variables, it's very hard to visualize them. Although 3D visualization is not very recommended. I talk about the visualization techniques later. So instead of 0 and 1, let's find a better name. And let's see what's the differences between these two clusters. You can look at the several variables and to see how those variables are different, these two clusters. I look at the tourist arrival. So I said group by my data frame is df, by cluster label. So the labels are 0 and 1. And then look at the mean of tourist arrival. As you see in cluster 0, the mean of tourist arrival is 4 raised to power of times 10 raised to power of 6, which is 4 million. And for cluster with label 1 is about 1.8 times 10 raised to power of 7. As you see here, mean of the annual mean of tourists in cluster 1 is about 18 million people, versus in the cluster 0 is about 4 million. Again, this is the scientific format. You can convert it to regular formats or any other formats that you like, but anyway, so it just means the cluster 0, the annual mean of Annual tourists is about 4 million. In the cluster 1 is 18 million. So as you see, number of tourists in the category 1 is a lot more. So we call it more attractive countries, and 0 is less attractive. Or you can say countries that are in category 1 can make more money from tourists than category 0. But let's see uh, which factors are contributing in these differences. One of the ways that we can do some descriptive measure or predictive measure. So predictive measure, basically, now we have a label for each cluster. So we, in the next step, we can consider this as supervised learning, and we try to predict those labels. In the second phase, the accuracy of models is interesting, but what is more important, or what is more interesting, is that what is the factor that are contributing more in the prediction. Let's say that I know a variable that is very contributing in the predicting the category, so maybe those countries that are in category 0 can pay more attention and improve their tourist arrival rate. For the second part, which is basically supervised learning, I'm dropping the variables that I use for clustering and also the tourist arrival, because I want to see what other factors are contributing. So as you see with the drop method, I'm dropping those variables. Access one again means column. And then same as before, I want to have train set, test set, and holdout set. In the train set, I train my models. In test set, I look at the performance of my model, which, as I said here, is still important, but what is more interesting is finding the factors that are more important for prediction of the clusters. So right now, I have supervised learning, and my dependent variable is cluster label. So same as before, we have 3 feature selection method, then we merge all of the features. I don't explain that much here because we already had one session about feature selection. If you have further question, please let me know. Maybe I can make a new video for them, or you can just stop by my office and we can see how can I help you. But for today, let me just skip it. But again, we have like one method which is filter-based method based on statistical correlation. Another one wrapper method, but as explanation here, I'm using SVC, support vector for classification. If you might remember previously, we had that wrapper method with SVR, which is support vector for regression. In that one, we try to predict a continuous variable, but in this lecture, we are trying to predict class of the features, or class of, observations. So class is either class 0 or class 1, or class of less attractive and more attractive countries. So it's a classification problem. So instead of SVR, I'm using SVC. So the only difference with the previous one, that here we are using SVC, which is for classification. And as you see, it just told me that 7, the best number of variables is 7. So I try to use 7 variables for feature selection. So in the next block, I'm using 7 variables for feature selection, because I already know that it gives me the best predictive performance. So at the end, I have these 7 variables. Then I use lasso. Again, previously I used another type of lasso. Here I just use lasso. You can compare these two, but they are pretty much same. So after doing feature selection, we merge all the features, and as you see, I make a array object that has I merge all of the features from our wrapper method, lasso, and filter method. Basically, lasso is the embedded method, which is something between filter and wrapper method. Then we want just focus on the features that are important and or features that we selected through the algorithm. So as you see for train set, test set, and holdout set in the independent side, I just select the columns that I already found are important. And we do prediction actually, but just keep in mind we train our model over the train set. We test its performance in the test set. Also, we have a holdout set, which is a data set separated from our data. And we want to see what would be the performance of our model in this as one data set that is completely independent from our current set. Uh, we would be happy if the performance of our algorithm, I mean accuracy, the accuracy in the train set, test set, and holdout set, in all of them, if they is close. Here in this lecture, I don't look at the performance, but if you might remember, we had a session that in that session, our performance of algorithm was too low, so we had a grid search. We tried to tune some options in our model to have a better accuracy. Here, I don't go in that. I'm just showing you that I use random forest, which is a I use a classification type of it. So a classification random forest, not regression, because here we have our dependent variable has two classes. I train my model through the feed method, and I do prediction. I don't look at the performance of the prediction in the especially test set. So let me change the name to the test here. But I assume that performance is pretty good. It may or may not. If the performance in the holdout set and test set is not good, maybe you have to change some settings, or maybe you look at your features that you selected and try to find a better model tuning or better features to have a better performance. Anyway, I do prediction, then I look at the importance of the features. As you see, first of all, the summation would be 1, the summation of all the importances. And we look at the relative importance here. So at the end, the summation of all importance should be 1. And it's distributed over all the variables. This is the importance of the features based on their order. This is the name, and I made a data frame here. So in one column I have features name, on the other one their importance, and as you see, again, I sort the data frame. So as you see, infant mortality is the most important, then life male, life female, education of female and education of male, and TFR. So what does it mean actually? So we had the clustering, and we look at the difference of cluster in terms of just one variable, which was the tourist arrival. Maybe on top of tourist arrival, you can look at all the more than one variable or some variables together, and try to see how you can to predict those labels and what is the most important features for prediction. So what does it mean? It means if you want to have more tourist arrival, maybe you can invest on your people, like for example trying to improve your infant mortality rate, basically invest in your healthcare, and also improving the life of male and female. These are basically expected life for male and female. Again, although the dependent variable is tourist arrival, maybe if you have healthier people and more educated, as you see, the fourth and fifth important variables are female and male educations. It has some correlative effects on how many tourists you get. It might be interesting, but at the end of this project, maybe you can recommend for having more tourists, maybe it's better to invest on your healthcare, because your model shows that uh, countries that have more tourists probably have better healthcare measure, and those measures are infant mortality, life male, female, and education. Also, as we see, investing in education is very important. As you see, although you might expect that if you have more people, you have a very large country like India, China, United States, or Brazil, they are very heavily populated countries, is not really important variable. The more important variable is healthcare and education. So, and you know what? As I said, looking at the prediction accuracy here is very important. I don't think it's not important, but since it's not a topic for today, I don't look at that. But the most important thing for somebody who's studying analytics is providing insights to the people, to the countries, or to the company. So you do some analytics, but and you learn how to do Python or other algorithms or algorithm in the programming languages. What I mean algorithm, like you can at the end of your education, you understand what is the random forest, neural network, SVM, or other algorithms more in depth. But the most important thing, your recommendation, your insight, your analysis. So for your project, what I expect from you at the end of this block, you put some conclusion. So let me change the cell type to markdown. So let me just put a conclusion. For improving tourist industry, investment in healthcare and education is highly recommended because these are more important variables in predicting cluster of countries in terms of tourist attractiveness or arrivals. So basically, the last phrase is really important and critical for you guys. And as you see, just look at the made ups of my or ingredients of my cluster based on just one variable of tourist arrival. Maybe you can look at the several variables. It makes and you can provide more insight. Here, there's just one conclusion for one variable. Maybe if you want to look at some variables together, or maybe for each variable you do a separate prediction things, you have more insight. But I strongly recommend to invest further. Don't just leave accuracy codes. I really the more important thing that I look at your project is your conclusion, your insights, how you approach to the problem, how you did the investigation. Okay, thank you very much, and I hope you end up having good insights. If some codes are more difficult for you to understand, please divide it into smaller parts. And also, you can just hit me. Maybe you can send me your question. If I see several questions from you guys, maybe I can go to some specific part of codes more in details or provide more examples. You are more than welcome to stop by my office during my office hours, or just shoot me an email. Maybe we can have an appointment for other more than opportunities than just my office hours. Thank you very much and have a great day.